Hello, everyone, and welcome. I'm Simeone Scaramozzino, and I'm the leader of the Milan chapter of Transformative Technology. We are a global community of entrepreneurs, innovators, scientists, academics, practitioners of all walks of life, professionally and personally, who leverage technology to bring transformation into our work and society. We believe that tech and the infinitizing power of tech can truly help humans expand in directions and unprecedented directions. And today we are here with Andreas Forsland, who is the founder and CEO of Cognixion, a company that truly epitomizes the TransTech mission, because it's a group of people that orchestrate so many different types of technology with one big goal: deeply transforming and affecting the lives of 100 million people with challenges, different types of challenges around the world. Very, very welcome to Andreas Forsland. Today, we're going to talk about Andreas' vision for societal transformation and how the universal design principle is integrated in the solutions, the products, and the services that Andreas and his company are bringing to fruition for people to learn, and for people to express, and for people to be included in society, and ultimately for their physical features to be augmented. The word to you, Andreas. Welcome. Tell us a few words about your background.
Thank you, Simeone. I appreciate that. Welcome, everybody. And well, you know, I'm in California here, so it's the morning for me. For many of you, it's the late evening and any time in between. So thank you for taking the time with us today for this conversation. You know, my background is design. So I've started my career in the 90s working in digital technology, thinking about user interface design. And so over the years, I've been exposed to lots of different aspects of human factors and how to design things for the internet and for small devices and TVs and set-top boxes. And then later I got into healthcare, working at Philips Electronics. I was in their design group, working across healthcare, consumer electronics, and lighting, really thinking about what's next around society and how different kinds of technologies could sort of start to integrate into the daily living while starting to disappear into the ambient environment. So a lot of the things that we see around us today, around the built environment and smart homes, around more natural user interfaces regarding touch ID, you know, fingerprints and facial recognition, these are all things that I was exposed to about 10 years ago and in the early days of technology before there was really a market for it. But how I came to do what we're doing now, I started this company Cognixion. It was previously called a company called SmartStones when we started in 2014. And in 2017, we pivoted the company and called it Cognixion. And I'll tell you a little bit more about why. But the real genesis for why I created the company in the first place was a personal story that I'm sure some of you may be able to relate to. So my mother, well, as a young boy, I was raised, I was an only child, and I had, my father was older. So my dad was actually 74 when I was born. So it was kind of an interesting fact of such an elderly father. But long story short, by the time I turned 14, he had developed early dementia and then it became into Alzheimer's. So at a young age, I learned pretty early what it was like the stress and the mental anxiety around caring for someone who has a mental disorder and it's degrading or it's progressing. And so the understanding of cognitive abilities and how to adapt as a caregiver around that, I sort of learned intrinsically as a boy. And then so as in 2012, fast forward to a more recent time, my mom was coming to visit with us in California, and when she turned 70 for her birthday. And when she arrived, she wasn't feeling well. And it turned out that she had a very aggressive pneumonia. And so overnight, she was admitted into the ICU with a very aggressive pneumonia, went into septic shock, was going into kidney failure. And they put her on life support, and she was in the ICU intensive care unit on a ventilator for about 7 weeks. She did survive, but it was a very long recovery process. And during that entire time of 7 weeks, she was unable to speak because she was on a ventilator. And so this was in 2012. And so if you think about what's happening all around the world now with coronavirus and the effects of how rapidly it takes hold of individuals with great surprise, it's very difficult to respond to that. And so what you're left with is my lived experience. Millions of people are living that experience today. And so I have great humility and empathy to share with you my story, and also the kind of technology that we're creating that basically focuses on enabling people that are in a physically limited situation to be able to communicate on their behalf when they are unable to communicate. And so that was inspired by my mom's inability to communicate in the hospital because she had a ventilator.
Thank you.
So,
wow.
Yeah, so that's my personal story. Now I can go into great detail on lots of other things, but that was really the genesis.
Yeah. Thank you for sharing. And I when we first spoke about it, what I was really struck by was your idea of building, of transforming a society by starting with solving the problem of niches of society. Now, a society that tends to massify and to go for the big numbers first, and then extend, or maybe leave some of the smaller niches out of the game. You instead said, we need to focus on them first, and then extend the know-how that we have developed and the technology we have developed to the entire society. I think that is beautiful. I want you to spend a couple of minutes on this, if you could.
Of course, yeah. I don't know how many people on the call are familiar with the idea of universal design, but it essentially the principles of it are, by designing for the least of us, we benefit the most of us. And so oftentimes that means starting with a very unique use case that is very helpful to an individual. And then you look at how many other individuals share that kind of circumstance. So for instance, a curb cut in the sidewalk is considered universal design because it was originally designed for accessibility for people with wheelchairs. Well, guess what? Now that people with wheelchairs that can cross the road easily, so can people with a low gait, so can people that shuffle their feet, so can small children, so can people with walkers, so can bicyclists, so can everybody, right? So by focusing on a unique need, the world benefits when you can adopt it universally. And so same thing with motion sensors. Motion sensors were designed with a specific need, and then they were adapted into automated front doors for stores. And now who wouldn't expect the doors at a grocery store to automatically open or close? So these are expectations that people start to have around universal design. So for us, we really see the world, a more just world that is inclusive, and that universal design approaches are what's going to help get us there. By not trying to address the needs of billions of people all at once, but by focusing on a specific problem that can be solved, that if you understand kind of the ripple effects, if you can break that down into its most universal basic parts, that by solving that problem, you can see connecting the dots between all these other opportunities that benefit others, it becomes really gratifying because you can focus your attention on solving a problem very, very well, and knowing that there could be potential adoption of that technology in other areas.
Yeah. And Speak Pros seem to integrate so many technologies, and I'm just fascinated by having you tell us a bit more about the process of integration and the path to education, right, on such a product that is such a like game changer in the field of impairments. Could you spend a little bit more touching on it?
Sure. Well, we're focused purely on solving right now. We're focused on solving the problem for people that cannot speak or have very difficult time speaking. So just specifically, so we're talking about small numbers or big numbers. So by context, if you add vision, hearing, and speech disabilities, if you combine those three, it's over 1 billion people worldwide. So roughly 20% of the world has vision, hearing, and speech disabilities. Of those three, over 500 million, so more than half of those are speech. And if you break down speech into its segments, there's about 100 different clinical pathologies that fall into that speech disability. So when you think about the sheer variety, over 160 different unique needs, it requires a deep framework, a philosophy for personalization. So how can you personalize the ability for all these different kinds of use cases to be able to access communication easily in a way that is humane to them and can respect them and whatever their needs are. So if they're highly literate and they're quadriplegic, or they've had a spinal cord injury or a brain injury, that's very different than a 13-year-old with autism that's nonverbal, right? So you've got a wide spectrum of sort of parameters that we have to design for. So I think what we've tried to do is understand cognitively and motorically, physically, all of these different situations, and started to look at what are those shared values, what are shared experiences, and then what we've tried to do is build a technical framework that will allow us to make it possible for people to personalize their own experiences so that they can access communication with less effort. So sometimes that may mean, when you're saying we've integrated varieties of technologies, different people need to access an interface, basically. So if you think about Speak Pros, you mentioned, which is an app that we have available on the Apple App Store, so it's an iOS today. That app accommodates a variety of different access methods, right? So for someone who has chorea, so chorea is a disability that makes it very difficult. Like you might see people that are wiggling around in their wheelchair like this, or they have a very difficult time moving. That's called chorea. So for individuals that have chorea, you need a specific way to offset that calibration so that they can touch a screen or they can control the screen. So we support what's called switch access, which is if they have a push button, they can push a button and they can scan the screen up and down and select things. We support facial recognition and eye tracking within the device. So we actually can monitor their face, and based on what they're looking at, they can click things by smiling or blinking. So there's a variety of ways that we can make it possible within one application for somebody to access communication and personalize it for their needs. And that's really a big focus around this idea of how do you apply artificial intelligence or machine learning to an accessibility problem, right? And because it's very difficult to do just with toggles. You can't just do it with toggles, right? You actually have to have some software running that is actually processing information and adapting to the person in real time.
During our previous talk, you were telling us how the first beautiful integration you created in the platform of life, which is a concept I'd like to talk with you again during this conversation, that to make this company truly understand and being empathetic with the issues that the company has to solve, you actually have people with impairments in your own organization. Could you tell us more about how that is easy, to integrate in a society that has that's constantly driven by all style performance parameters? And how is the flow in your company affected by integrating, by being the epitome of integration?
That's I have to sigh for this one because it's oftentimes there's a lot of lip service given to what you say and what you do. So there's a lot of corporate communication that comes out of big companies and small companies that sort of proselytize of what you should do, but they don't do it themselves. And in the history of my career, especially in developing products and design, in design, you use all kinds of tools to try and understand the market and understand the user, right? So you have tools internally like personas, and you try and figure out using research to simulate or synthesize a bunch of information to understand and build empathy internally around who you're trying to solve problems for. Well, that's a layer of abstraction, which is interesting. But what's more interesting is if you could actually walk the talk and say, if you believe that the world should be inclusive, then you should start within your own organization, right? And if you think you need to design for people that have a disability, or if you have to design for anything other than yourself, then it should be correct to invite those people to design with you, right? So co-design with the end users and actually hiring individuals to be a part of that process is paramount if you believe in what you're trying to do. And so I think there's an integrity piece that large companies need to, if they're going to serve a market, they should find a way to integrate that market into what they do.
Thank you. Thank you. How hard was it for you to bring the vision to fruition? You seem to, again, sorry to touch on this again, but I'm particularly interested. There's so much integration needed, right, amongst the different technologies that you're working on. And especially in light of that, again, beautiful representation of life that you have in mind when we spoke about life being a big platform, right, and imagining all the solutions being applications. I find it fascinating, but also very challenging. And so how do you pull it off?
You're right on both of those. It's just around, the operations of a business is around, affecting, achieving a goal with the least amount of energy expended, right? And so, by doing so, it forces you to think about the bigger picture and know that you're concerning yourself with the world, but synthesizing it into a scope that you can execute, right? And so by narrowly defining the scope that you can execute, then that's sort of how we're dealing with kind of the overwhelming nature of it. So as an example, but I'm going to ramble here for a moment, but things are moving very, very quickly. And when you think about a platform, right? So if you think about individuals with disabilities for a moment, oftentimes technologies that have been designed for individuals with disabilities, they've started out as mom and pop kind of things, right? Like a family member that might be an engineer comes up with an idea and just wants to do it for their child. And then maybe a few more people buy that product, but it becomes a cottage industry. So there's lots and lots of, literally there's thousands of applications out there that do different things. And so it's this interesting kind of industry, but nobody's ever come or sort of had the audacity like we do to come in and say, you know what, there's probably a better way to make a bigger impact. So today there's, like I said, there's 500 million people worldwide that have a speech disability, but only about 3% of those people, 3% of them have access to technology, right? So when we think about what we're solving, we're not just solving a technology problem, right? Or a design problem. We're trying to solve an access problem, so how do you deal with distribution, and how do you get more technology into the hands of more people? So how do you make it affordable? How do you make it easy and localized because they have their own language needs? maybe their own vernacular needs. So by focusing on speech, and then we narrow it regionally. So right now we're focused on English at the moment, because we're leveraging language systems. And so language, so we're trying to build natural language understanding and a semantic understanding of what people are trying to communicate so that we can help them do it faster. So we've narrowed our initial scope to English, but we do work with others to localize. But this platform idea, today, the distribution platform is broken for a lot of people. And so if you need any kind of physical supports or augmentation, you need to get that through insurance, or you need to get it through a clinical evaluation, right? Versus I just want to go and get it myself. I want to just download it out of an app store. And so I think we're going to see a tipping point when there's more stuff that is clinically endorsed, but the regulations will allow for people to pick things up on their own, sort of, and being able to pick up those devices out of the app stores or be able to pull them off of Amazon.com and get a Prime order. When people can start to take control of accessing affordable things that are easy to get, that are intuitive to set up, that's really where we're going to see a big tipping point. And Cognixion is a small company focusing on this problem, but I think by aligning a vision with partners, so like if Amazon wanted to get involved and help accelerate transformation for people with disabilities, this is exactly the kind of thing that they could make a huge difference in. If Apple or Samsung wanted to get involved in making a huge difference, then taking technology like ours and making it prolific, making it available and accessible to everybody would make a huge difference, right? Because there's, through partnerships, you can reach the world. Otherwise, it's going to be it's a long transformation, So, I think we looked at it really pragmatically and said, based on the business fundamentals of like an acquisition model, so the cost to acquire a single user and to support that user to come online and come on board under our own power, so dollar for dollar, like what would it cost for us to make a difference in 100 million lives? And, it might cost us $1 billion to change the lives of 100 million people. But then if we look at, the $1 billion to spend to bring 100 million people onto the platform, imagine what the world looks like now, where you have new ideas and new voices being expressed. You have people fulfilling themselves. You have artists, you have scientists, you have architects, you have people that can do things that they were otherwise marginalized. And not just what they can do, but the network effect, right? So for any individual that has a disability, they have a family, they have friends, they have their first and second and third degree circles in their social graph that also benefit by that individual being empowered, right? And so I think there's this huge ripple effect that can happen by approaching the bigger problem in a first principles kind of way and figuring out how to cause that sort of pebble in the water, we're the pebble in the water, but it takes partners to make those ripples go far. So.
Thank you. It certainly, it is not a pebble in the water, but the app that I would really like you to show us around a bit and perhaps show us the user interface, or if you have anything that can express thoroughly what the app does and what how the technologies are integrated, and the user experience, and all the different surroundings, conclusions around it, so to speak.
Sure, absolutely. Would it be okay to share my screen?
Yeah, absolutely.
Okay. Let's see. So one of the things I also wanted to mention was that, when you think about platforms that are globally accessible, you go to mobile, right? So mobile hardware. And so that's where we focused our attention. But in the bigger plan, we believe that there's a better form factor. We believe there's a better, a wearable form factor that kind of would be the ultimate accessibility interface, and I'm going to kind of talk a little bit about that here. But so a little preamble on some of these slides. So, when you asked, about our team, our team's about 14 people. We're going to be about 16 in July. So we're growing. But if you look at the composition of our team, we're 50-50 female male split. We have many languages and many cultures, even in such a small team, that are represented. And we also have individuals with autism, ALS, spinal cord injury, and a stroke who have they all contribute to the work we're doing on the design and human factors aspects. We also have two individuals, one with cerebral palsy and one who's quadriplegic due to a car accident, who are both on our sales team. So we really try and integrate and walk the talk in the sense of including everybody's voice in the work that we're doing, and building a relatively flat organization. We're headquartered, so I'm sitting in Santa Barbara, California, and we're also based in Toronto, Ontario. So we have an R&D engineering team in Toronto, and we have a small satellite of someone in Phoenix, Arizona, as well as Pittsburgh, Pennsylvania. So, we currently are operating mostly through Zoom and Teams and GoToMeeting and these things. Our Santa Barbara office has come back together, so we've actually reintegrated our Santa Barbara team, but everyone else is working virtually. So our mission, so a lot of you might be able to connect the dots here, but Stephen Hawking is kind of an icon and a very easy person for us to point to represent the ideals of what we're trying to do. And if you look at someone like him, he could have very easily been marginalized and just excluded from society because of his not having access to self-expression. He was a lucky one because he had lots of really fantastic resources that circled around him to support him. But he's one of hundreds of millions of people. And so our goal is really, how can we leverage technology and smart ways of distribution so that we can get many more people like Stephen Hawking out there sharing their ideas. We're also working with a number of institutions, primarily in Canada, but we're working with the University of Waterloo, the National Institute for Scientific Research, York University, Western Ryerson. We're also working with the Healthy Brains, Healthy Lives. We have a strong position with the International Neuroethics Society, understanding the ethical use of biodata, biometrics, and how we handle information that's personal, et cetera. So we also have a number of clinical relationships that range from speech therapy to behavioral therapy, ABA. We've been written up a number of times around being on the top 20 list of most promising AI companies. We're on CB Insight, is a popular analyst publication. They rated us as a top 21 neurotech companies to watch. So we're starting to raise visibility in what we're doing. But really what we're trying to create, which Cognixion is really destined to become a restorative bionic interface for 1 billion people, right? That's our vision, is how can we create an interface that truly augments someone's ability and serves their needs and makes it possible for them to do what they otherwise couldn't. And then thinking about that social impact, this is very important because everybody is connected to a large number of other people. So whether it's strangers, friends, teachers, parents, clinicians, caregivers, or doctors, the last one on the lower right, police, is one that's often overlooked. But if you think about, you might hear news every once in a while of, say, a teenager with autism that might be eloped and had a bad confrontation with the police because the police weren't trained on how to communicate or understand the behavioral cues that are given by someone with Asperger's or severe nonverbal autism. So sometimes you have some pretty bad circumstances if you don't have access to communication. And what we're trying to do is address that root cause need. When we looked at the 100 million that is a subset of this, about 48% of those have strokes. About 23% of those are traumatic brain injuries that can either come from physical trauma to the brain or other kinds of infections that affect the brain. But it also includes ALS, Parkinson's, cerebral palsy, MS, Down syndrome, and cancer, and autism. So these are all areas that we've studied deeply, and we understand a lot of how to design for human factors for these individuals. Sorry about that. Sorry about that. So if you look at the overall opportunity, we look at it as a spectrum. So individuals who are born with a disability, all the way to individuals who have acquired a disability. So if you put these on a spectrum, there's a different time horizon around their cognitive and linguistic abilities. So as they're starting to develop receptive and expressive language, that happens developmentally at a young age and over their youth. And oftentimes individuals who are young adults or seniors, they have their existing expressive language abilities and the cognitive abilities may be intact, but something happens to their physical abilities that reduces their communicative skills. So when we simply look at all of these different conditions, we boil them down into what's their intention and how do they get it out? How do they accomplish that intention? So I try and reframe this idea of an IO. So in technical jargon, IO means input-output, which has to do with the user interface. We take one step further than that of understanding it from intention and outcome. So what is the intention you're trying to do, and how can you achieve that outcome? And then how can we reduce the amount of time and energy expended to achieve that? So that's the compression of time and sort of the perception of time as well as literal time to being able to accomplish that. And the reason being, if you apply that to communication, if you've ever walked up to someone with a disability, sometimes it takes them a little while. It takes them a longer time for them to process what you're asking and to respond in kind. And so oftentimes when you have a neurotypical and someone with a disability communicating, there's a breakdown because there's an expectation around how quickly they can respond. And if they don't respond quickly enough, oftentimes that causes disengagement, where they may just disengage from the conversation or lose patience. And so for us, by focusing AI and an understanding of the human factors through this design lens, then it becomes really around how can we enable someone to respond more quickly and get to the words they want to say faster, maybe not grammatically correct, but they can express themselves faster so that they could have multiple iterations on a conversation. Because when you can address that time envelope, then you can actually start to move your way closer towards relationships. So that's really when we look at this and we say, well, what's your intention to speak or intention to move or intention to control something that's further away that you can't reach? And then physically, how do you do it? Do you do it with your finger if you can touch it? Do you do it with your toe? We actually have people who type on our keyboards with their toes. Can you use your neck? If you can't use your hand, can you use your neck and ambulatory ability? If you can't move your head very well or you don't have neck control, can you use your eyes, right? And then you start to say, well, historically, the sense of last resort as a control interface has been eye tracking. You really couldn't, if you're not compatible with eye tracking, then you're really stuck. You can't, there's nothing else. And so we're working on that, extending that ability through a direct brain interface where you can actually move beyond just eye tracking into a brain interface that can essentially control and understand intention to drive an interface.
In how many?
There's a number of types of.
Yeah. That's exactly where I was headed to. Yeah. Mm-hmm. In how many products do integrate this beautiful vision today? So that's where you are headed.
Yeah. In today's world, there's a number of solutions that are out there that do different things. So there's devices that focus on touch access. There's devices that use EMG and muscle movement. There's devices that use medical grade eye tracking. And then there's EEG-based solutions, and also what's called ECOG. ECOG are implants. So you maybe heard of BrainGate and other implantables that are being used as subcortical brain interfaces. But these are very, very expensive, right? All of these solutions are extremely expensive for someone to pay for out of pocket, which is why there's a strong reliance on medical and healthcare and insurance. So that's today's situation, and it's in the US, and it's also pretty much everywhere else in the world. It's the same situation around how can I access it, how can I afford it, how can I get up and use it. But today there is no brain interface for communication. We're literally the only one. I wouldn't say we're the only ones, but we're the furthest along in developing a direct brain computer interface for communication. So when we think about making the world more accessible for everyone, I mentioned this earlier, statistically about 20% of the world currently has a disability. But here's the thing. Every one of us on this call, we're just temporarily abled. We're temporarily given the blessing of having an able body. And at some point in life, almost everybody will be augmented in some way, right? We all will be augmented with some kind of prosthetic or some kind of sensory aid, whether that's eyeglasses, hearing aids, cochlear implants, contact lenses, pacemakers, things like this, other kinds of implants, stents. So a lot of these things are all augmentations to extend our life and improve the quality of life while we have it. So I think by focusing all of our attention and efforts and energy into designing for people with disabilities, you truly are designing for everyone, because eventually we all may end up needing to use the tools that we're creating today. Accessing the platform, so there's things that people want to do, and these are the areas we've been looking at. So you said, how do you deal with all of this? And so it's by prioritization. So people want to learn and grow, they want to communicate, they want to control things, and they want to access services. So we've intentionally narrowed our scope to communication, and now we're starting to expand that from communication to communicating and controlling. So now you can communicate and control things with our interface. So what we have today is a platform that basically can use multiple access methods and personalize them, whether it's a gesture interface, gesture recognition or head motion, facial expressions, eye gaze, EMG, muscle inputs, EEG, brain inputs, and also proximity sensing. And we're working on two form factors. So one is a mobile solution and the other is a wearable solution. And both of them are going to have an AI assistant that's built in. So the AI assistant that's built in is going to aid in enrichment and fulfilling those other services to learn and grow, to control things, and to access services. So our core has started with communication, but we're leveraging AI companionship to fulfill those other things that individuals desire. Today, we have an app that's in the App Store. It's called Speak Pros, and it's a communication application. So essentially, it's got a language system built into it that makes it easier and faster to assemble expressions. So you can assemble sentences through word prediction and being able to very simply tap certain words and play them aloud. And if you can't tap them, then you can use eye tracking to guide the cursor around and blink or smile or dwell on the different words to assemble them as an interface. And you can see the woman on the right she has cerebral palsy, and she's leaning way back in her wheelchair. So using a mounting bracket with an iPad, she can mount it so that it's comfortable, and she can essentially now communicate. And she's in her 50s and she's never spoken in her life. And now she's able to communicate with the people around her. So that's just one example of what we're doing. And I could actually give you a demo live, or if you're interested or you know somebody who might be interested in this, I'd be happy connect you or them with somebody on our team that can give you more information on this. But we also have clinical speech pathologists on staff. So if we need to have someone provide more insight around an evaluation, we can help with that for matching for a particular patient.
Wonderful, wonderful. Thank you.
But what's even more exciting is because we've used the mobile as a sandbox, so it's already prolific, so devices are everywhere, so it helps us solve that distribution problem. We're going to be, early 2021, we're going to be making a wearable available. That's a heads-up display that includes augmented reality and a BCI. So it's a complete integrated system that includes the BCI electronics using EEG, as well as the accessibility of using head gaze and other things for controlling the AR environment. So essentially, it's one elegant solution that can accommodate a variety of access methods within a very simple form factor. And so I'm going to jump to so I have some videos of somebody. Let me see. I'm gonna reduce this for a moment. So I'm not sure how the audio is going to work here. We can give it a shot. But here's, I can show you an example of a video let's see if it plays through. If these videos don't play well through Zoom, I'm happy to send you a link to them.
Using this headset, has it been the first time that you've ever been able to communicate? Okay. Has this made your life better? Okay. Are you looking forward to using this some more? Okay, are you ready to remove the headset? No. Oh man, she's having too much fun.
So for the sake of time, I mean, I have loads and loads of videos of beta testers and other folks who are using our technology. But it's just, it goes, if you noticed, that was literally the first time she ever wore it. So we just put it on her head, we gave her some basic instructions, and she was navigating within seconds. So if you think about that time envelope around time to value, the speed at which somebody can experience the value proposition that you're trying to create, it's paramount that they have that epiphany, like, aha, this is how I do it, and that they feel like they're in control of their world as fast as possible. You don't get that kind of visceral expression of joy. Like we don't, I mean, we see a lot of joy with the tablets, but the joy that comes along with the magic of having a heads-up display that you can use to communicate and still have eye contact with each other. You can make facial contact both ways. It's really powerful. It's very emotional to see.
Thank you for sharing. Before we open to the Q&A, I have one last question about regulation. Is regulation helping, supporting, or hindering the process of bringing transformation into the world through your products?
Regulation. It's a double-edged sword, right? It slows things down in order to maintain quality. But when you have existing systems that are of the highest quality in the world, you know, so by leveraging technology, so for the iPads as an example, right? I mean, you're not going to get tablets that are any better than that, you know, so then it comes down to other things around use cases, around applications. So how do you clean them? Can they be sanitized? Can they be shared between users? Do they need to be dedicated to that user? So there's a lot of regulatory stuff that has to do with prescribing a technology for an individual that insurance will pay for. Mm-hmm. The other thing is medical necessity. So there's a lot of time involved. So time is kind of our enemy on this in the sense that it takes a lot of time and effort to get together in person for a clinician to work with a patient to present different technologies to them. because they have to show multiple options, and then based on which one the patient prefers, then they then process that chosen one through insurance, which takes a long time. So it can literally take 120 days from getting the first evaluation to getting it in your hands and using it through insurance. So for some people, 120 days, that could be life or death. You know, so it's the time horizon related to regulation is what is the barrier, I think, more than anything else.
Thank you. Thank you. Opening to Don. I think some of you, part of your question was already answered, but Don Dulcinos, he's in the TransTech community, is asking, does eye tracking or facial recognition happen through the app and capabilities of the phone or the iPad, or are there any external input devices, e.g. switch or a BCI EEG headset? I think some of it is already tackled, but feel free to...
Yeah, so the first question, sorry about all the bings here. My phone is connected to my laptop, and even though I have my phone muted, I need to tell Apple, like, stop doing that. When I put my phone on airplane mode, my laptop does not go into airplane mode. So is the eye tracking and facial recognition in the app, or is it in the device? And it's in the app. So the app, we're able to do it because there's a depth sensor. So there's an infrared camera that's projecting infrared light on iPhone 10 or newer and iPad Pro or newer, the third gen. So those newer iOS devices have an onboard camera for depth camera that uses the infrared light. So we're able to use Apple's hardware, but there is no existing Apple eye tracking facial recognition capabilities that do what we do. And so we're pretty much the software end of it.
Thanks.
Yeah.
From Jackie, how does digital accessibility guidelines such as WCAG contribute to design of speak pros? What are the challenges in having insurance providers cover the cost for unprivileged patients with aphasia?
Might need to, those are two meaty questions. So, you know, so accessibility guidelines around how we've designed Speak Pros are guidelines. The challenge has been in who we've been designing it for. So for instance, it's not designed for people with low vision. So there's a number of guidelines around vision and accommodations there, voiceover support and things like that. But essentially what we've done is we've employed as much of the required accessibility features as we can within the application, within reason. As a speech generating device, it's mainly about accommodating, say, guided access so that you can lock the application for the specific user, that we can turn on and off voiceover. So if somebody is low vision, you can still navigate with that. It does support switch access. So if you want to use the native switch controls and configure that with a Bluetooth a switch, you can use that. So hopefully I answered that question. Could you re-ask the second question? It had to do with insurance. That's
yeah. What are the challenges in having insurance providers cover the cost for unprivileged patients with aphasia?
Aphasia is difficult. I'm going to say that. Aphasia is difficult to understand from a linguistic perspective. I think the insurance piece isn't the difficult part. It's actually, there are very few companies that are solving aphasia very well, because essentially aphasia is really around understanding the scene that's around you. We've been looking into aphasia. It's a challenge because typically if you want to address aphasia, you really need to do, like mixed reality would be fantastic for aphasia, because you can do SLAM and you can sort of mesh the environment around you. And so you can build object recognition, which can aid in supporting someone who's aphasic. For aphasia, you know what some of the words are. but they don't come out. So an example might be you show someone a writing pen, and they might call it a paper skate, and you're like, what's a paper skate? And it's like, oh, well, this thing's skating across the paper, and it's like, how would you correlate and map pen to paper skate? And so there's some very complex lexical structures that you would have to design for aphasia that's very different than other disabilities.
Thank you. I think we have a lot of questions and only 6 minutes left. If you're all agreeable, we can extend by, 5 or 10 extra minutes to have all of them addressed. What about you, Andreas? What do you think?
Yeah, I'm fine with that.
Okay.
I'm enjoying these conversations.
All right, wonderful. So from Slava, what speed of communication were you able to achieve for different types cases in words per minute?
It's extremely individualized. It really is. So, sort of the target, the target for read language is around 150 words per minute, right? So that's kind of the neurotypical target that we're trying to help people get towards. But you may have an individual that has developmental disabilities where they might take 30 seconds to get 2 words out. Yeah. And then you may have someone with ALS who formerly was a lawyer, and they're saying that the system is too slow, like it doesn't perform fast enough for them, and they might be able to do 200 words per minute using eye tracking with predictive text. And so there's a wide spectrum of perception and accommodations, I guess. And so I wish I could answer your question directly, but what we've found is that we've been looking at an order of magnitude greater than any incumbents that are in the market. So it's easier for us to say what's in the market today and what is sort of a baseline based on a certain user type or a person in a situation. And the existing systems that are out there today, most of them are called symbol systems, which use illustrations like stick figure drawings of different situations, like flashcards. And there's usually a word associated with those flashcards. So people they're trained on understanding what these pictures mean, and they sort of assemble pictures into a string, and then they hit play. What we found is that our current interface is roughly 10 times faster than that for certain user types. And we can get more into that if you want to email me directly. I could tell you more.
Wonderful. Jackie Lee again. How does one assess if a patient has his or her language ability intact, for instance, amongst locked-in patients?
Typically, it's a progressive. So the way a locked-in patient accesses language today predominantly is with a speech therapist that's working directly with them face-to-face, and they're using some kind of letterboard. And so the presumption is that they understand what a letter is, what is a letter, and they understand a basic understanding of the alphabet. And so they're essentially conditioned to be spellers, is really common. So what a speech therapist will typically do is they will state every letter, A, B, C, D, E, F, G, and then they'll look for a physical indication that the user is responding to a certain letter, whether it's a physical movement, an eye, a slight glint in the eye. And that's the first level of conscious awareness of understanding, like, are they in there and are they responding consistently to the prompts to spell a letter. Usually it starts in a very primitive way with simply starting with yes and no. So the ability to go, left, like yes, no, yes, 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 no, right? And so it starts in a very primitive way. And so what we're doing is with the AR environment, we're enabling them to put yes and no on the holographic screen so that they can access yes or no. And that's usually the way to start to understand dialogue and begin an assessment process.
From Vimukti, do you test on cranial nerves and implants?
We do not. We have relationships with people who are doing implants and ECOGs. but we're not doing any work in that area ourselves.
Both Don and Jackie Lee are congratulating on the design and the integration of BCI and AR. How can we become better testers? Jeff E says. He's asking how people can become better testers.
Oh, if you'd like to, yes, we actually have, we're sourcing right now. We have a beta program that we're kicking off that we're going to be doing a number of tests through the end of the year. So if you want to email me, you can email me directly. And Simeone, if you want to just send out my email or Allison, that's
Jackie, if the user does not like the machine voice, can we calibrate the voice? Would it be helpful if a soon-to-be aphasic patient record their voice prior to an oral surgery or use of ventilator?
Yeah, there's a technology, there's several answers to that. One answer is the last one. Can you record their voice before they lose it? And the answer is yes. It's called voice banking. And there's a number of services out there that I can link you to if you're interested in that for voice banking. And then the other one is if we needed to use a synthesized voice that's not based on their voice, banked voice. There's a number of solutions out there. I think what voices are getting a lot better. You know, it used to be just there was one robotic voice. And the funny thing with Stephen Hawking, as an example, he had people proposing all kinds of other voices that were much more elegant and smooth and more humanistic. And he actually chose not to go with those voices because he had built a brand identity and his own personal identity was attached to this robotic voice. So he said, that's me. All right. And so people just they just identify with a voice. Inside of SpeakPros, we enable people to adjust. You can choose, today you can choose a boy, girl, man, or woman voice as a generic voice. They're quite elegant and very nice voices, but you can adjust the timbre, pitch, and speed. So you can tune them up or tune them down within the application. We're using Amazon Poly voices. So if you want to look into Amazon, they have a very, very good list of different kinds of voices that you could choose from. And they continue to deal with all kinds of native languages. And they're also dealing with some unusual, you know, minority languages in different countries. So you may take a look at Poly, P-O-L-L-Y. They're great.
Wonderful. I have a question. I remember you mentioning that your solutions, your products also work in disconnection from the internet. So
disconnection, I'm sorry, from?
Yeah, disconnected from the internet, from any networks.
Yeah. So this is something that we find to be very important. Is, you know, individuals, they don't always have a perfect network connection. They don't, and ultimately, for something to be successful, it needs to be completely wireless. You should not have any kind of toggles or leash to a connection. So we've designed it from the ground up to work offline. So we have an offline first paradigm where you should be able to work without an internet connection. And so that means that the BCI and the AR and everything is essentially independent. So if you're in a submarine or you're in outer space or you're just not anywhere near Wi-Fi, you should be able to still not lose your voice. And that's really paramount. That also doubles with our ethics view of being able to have your personal information is all local, right? So any PII is local, so that it's offline, so that there's no, you know, we do allow synchronization of some of your information into your own private cloud, but it's disambiguated from your PII.
So this is about data ethics. So we also discussed how this is important in a moment where biodata is very much rumored to be the next big wealth. So I like your approach that is defensive of people's privacy after all.
And they're in control, and if they choose to share it, then they can, but our default is that it's yours.
Yeah. The last question I had is, what's the role of music in your product? And sound and music?
Yeah, music is interesting. There's, ironically, so sound is very important. Haptics are very important. So we believe that for a truly augmentative experience, it needs to include sensory stimulation, right, through your sensosomatic system and understanding through skin and haptics and sound. So we're also considering the sort of spatial experience of what audio and vibrations can mean, both in the user interface to help enrich the interaction design, but also to be able to provide you with cues of what's going on in the environment. So these are areas that we're studying and we're designing into our solutions. We're not explicitly dealing with music, just because you have licensing issues. There's all kinds of things that have to do with that, which are beyond what we have the capacity to deal with at the moment. So
wonderful, wonderful. Thank you very much for being here today. Andreas, thank you for accepting our invitation. Thank you, everyone. I hope you enjoyed our conversation. And thank you, Alison. You've been instrumental in curating and making this happen. And what to say if not, until soon. Ciao, everyone.
Blessings. Ciao.